Hey guys, welcome back to another 9 of these grade 6 to 9 questions. As you don't worry, you haven't clicked on the wrong video. It says number 3. That's because number 2 has gone missing and I need to go find it. So I decided to record test 3 before test 2. I know it seems a bit weird, but either way, what I'm going to do, as usual, I'm going to go through it. I'm going to talk through my thought processes and hopefully help you identify some areas of weakness that you can go and study, but also help you really develop that exam technique and how I approach questions I've never seen before, because I've never seen any of these questions before, so it should be kind of interesting. But without further ado, let's just get into it. Pavel has a combination lock. It sets each part of the lock to a digit between 0 and 9 inclusive, so that is 10 possible numbers, right? If you include 0 in your counting. One possible way of doing this is shown in the diagram. So 0807, how many different ways? This is called the product rule for counting. And you should be fairly careful with this topic because it has some nuance to it. Because depending on the situation, you might need to just multiply, hence the term product rule. You might also need to divide or even subtract certain combinations as well. But here's how I approach this. Is we have essentially a combination lock, right? And it has 4 possibilities. God, ignore the slightly out of line. There we go. That's a bit more human. And there are a bunch of different possibilities for the codes, right? Now, one way to do this is you could obviously write down all of the different codes, but as I'm about to show you, that's not going to work very well. But here's what I prefer doing. This is the first digit of the number. How many possibilities can I choose? Well, I can choose anywhere from 0 to 9, so that's 10 possible numbers, right? There are 10 different digits that can go into the first one. Now, because all of the digits don't have to be different, because it hasn't told me that they have to be different, how many different digits can fit into this one? Again, it's 10, because don't forget I can repeat digits, because it hasn't told me I can't. There's also 10 in this next one, and 10 in the last one. Now, all you need to do is if there's 10 in this one and 10 in this one, then the total number of combinations is 10 times 10, because there are 10 different options for this one, 10 different options for this one. So this first digit can match with 10 different numbers, the second digit, 10 different numbers, third digit, 10 different numbers, and so on. So all we need to actually do is multiply all of these 10s together. And that's it, which would give you, of course, 1,000 combinations. Which is why you definitely don't want to be writing them all out. Now, Pavel decides that the first and third digits will be odd numbers and that the second and fourth digits will be even numbers greater than 0. How many different ways now? Well, again, I would always draw this little bar model. Made it a bit bigger this time so it's a bit easier to see. And think about how many different numbers can go into each slot. So the first and third digit have to be odd. So if we're thinking of the numbers between 0 and 9, let's write down all the odd numbers. We have 1, 3, 5, 7, and 9. So that's 5 possibilities can go into the first and third spaces, right? Now what about the second and fourth? Will be even numbers greater than 0. Well, that's fine because 0 is not an even number, but whatever. 2, 4, 6, 8. So there are 4 possibilities for these two. And once again, we do the exact same thing. We multiply all of these digits together. So that's 16 times 25, which is 400. 400. That's all you had to do for 4 marks in total. Again, if you use a bar model and just write down which digits can fit into each kind of slot, that would be the best way for you to be able to do this. Next, we have a pretty fat 6-mark question. Yeah, 6-mark question. So we have a curve with the equation x squared minus 4x plus 4, so that is a quadratic. And we have a line with a straight line, with the equation 2x minus 4. It intersects at 2 points, of course it will. Calculate the length of AB. So to calculate the length, here is what we need to do. So we have point A, point B. I have no idea if it actually looks like this, but that's fine for now. If I want to work out the length of a line going between A and B, I need the coordinates of A and B. Because as you guys may know from the way I do this, what I do is I break this up into a right angle triangle. And then we just use good old-fashioned Pythagoras to work out the hypotenuse of this triangle, okay? So we need to somehow work out the coordinates of A and B. So again, notice how I'm starting from the end. I need to work out the length of AB. Well, how can I do that? Well, I need the coordinates. Well, how can I get the coordinates? Well, what are A and B? They are points where the line and the curve intersect. So at that point, those two things are going to be equal to each other. So if you make these two things equal to each other, you can also do a substitute. You can also call this a substitution if you want. We have 2x minus 4 equals x squared minus 4x plus 4. So if I move the 2x over to the other side and the 4 to the minus 4 to the other side, we have x squared minus 6x, and that would be plus 8. Don't know why that took me so long, but anyways. And from here, all we need to do is solve this equation, and you can do this in multiple ways. Quadratic formula, you can use completing the square, you can factorize whatever you want to do. Is there an easy way to do it? Yes, we can actually just factorize this, minus 4 minus 2, just to give us the answer nice and quickly. Equals 0. So if x is equal to 4 and x equals 2, but remember, this is actually a simultaneous equation because I did the substitution. It's not good enough that I have the x coordinates, I need the y ones. How do you work out the y ones? I would sub them into this second equation here. You could sub it into the top equation and you get the same answer. But the bottom equation is a bit easier because if you look at the equation, it's y is 2x minus 4. So we have y is equal to 2 times 4 minus 4, which means, of course, y is just going to equal 4. So our first coordinate is 4, 4. I just realised I put the bracket around the wrong thing. That would actually make a difference in this case. So 2 times 4 is 8, minus 4 is 4. Doing the same thing over here. 2, 2, 4. 2 times 2 is 4, minus 4 is 0. So we get equals to 0. So our other coordinate is 2, 0. So if looking at this diagram, I'm going to make A 2, 0. I'm going to make B 4, 4. And now we can actually work out the length. Remember, when I do the length, what I like to do is I like to work out what the length of the bottom side is, which is the difference in the x coordinates. So the difference, it goes from 2 to 4, so the difference is 4. So difference is 2, sorry. It's because I was looking ahead. And then the height is the difference in the y coordinates. So 0 to 4 is a difference of 4. Which means the length AB is just going to be square root 2 squared plus 4 squared. I don't know if they want us to simplify the third, which we're probably going to get. It's square root, we have 2 squared is 4 plus 16. So it is going to be a third. So square root 20. It doesn't actually say to simplify the third at all. So we can actually leave it like that. And that would be our answer for 6 marks. So in terms of the maths that we did, it's not the worst thing in the world. But again, the thing I noticed that's stopping students from getting to the grade 8 and 9 is their process. They wouldn't necessarily know that this is what they need to do. That's the big barrier. So again, look, digest my thought process. I started from the end. What do I want? Okay, what do I need to get what I want? Okay, what have they given me? And I'm just working my way backwards. I wanted the length AB, which means I need the coordinates A and B. How can I get that? Well, they tell me that these two things intersect, so I need to equate them. Remember, they have to give you enough information to do the question. So that means all of this information is useful. All of it. We have a bunch of information. We've got a solid bar of metal in a cuboid shape. They give us the height and apparently the width and the length are the same. Yeah, okay. So, interesting, okay. So 2 of the sides are actually the same. They give us the mass, m, and they give us, if you notice, correct to 1 decimal place, 2 decimal place, nearest whole number. Find the value of the density of the metal to an appropriate degree of accuracy. This right here is a very interesting type of question because normally when you see something like this, your first thought goes to bounds. And we are going to use bounds. But the second this comes up is where students get a bit scared. So allow me to go through it. The first things first, we are going to do bounds. Okay. What we're going to do is we're going to find the smallest possible value for the density and the biggest possible value for the density. That's our first thing. In terms of this explanation, well, that's actually what I'm going to do to help teach you. So that's going to be fine. So whenever they say find it to an appropriate degree of accuracy, you're going to find the lower and upper bound. Okay? That is a step that you have to take. So let's start with the lower bound. Well, the first thing we need to do is talk about what density is. Density is just mass over volume. And volume in this case is just going to be d times d, so d squared, times h, right? So if I start with the lower bound, just because I want to, in fact we could even split our page in two and do lower on one side and we do higher on the other. Not higher, sorry, upper, let's use the proper terminology. If we start with the lower, well, what do I, and again, this is how I'd start. I wouldn't jump straight into it. I'd say, okay, how do I make D as small as humanly possible? Anything on the top of a fraction must be as small as possible. Anything on the bottom of the fraction has to be as big as humanly possible. The reason for this is, well, think about the m being as small as possible. Anything on top being as small as possible should hopefully make sense. If I make the numerator of a fraction smaller, the number gets smaller, right? So if I take 5 over 6 and I compare it to 1 over 6, all I've changed is the numerator, and yet 1 over 6 is a lot smaller. Now the denominator is where some students get a bit confused. But think about it. If I make the denominator bigger, it means I'm dividing by a bigger number, which means the number should be smaller. So again, taken as an example, if I take 1 over 2 and compare it to 1 over 4, the one with the bigger denominator, 1 over 4, is smaller. So you want everything on the bottom to be as big as humanly possible, everything on top to be as small as humanly possible. So we want the lower bound of m, we want the upper bound of d, and the upper bound of h. So m is 13.91 to 2 decimal places. So if I take the upper bound, that would be 13, and if you want, you can write them up here. So this is also something I teach some students if they find it a bit tricky. The upper bound would be 13.915. All you do is you add on a 5 at the end. That's all you do. And the lower bound, all you do is you subtract 1 from the middle number. So 13.905. If you do the same thing for D, D is 8.3 to 1 decimal place. So again, if I want the upper bound, all I'm going to do is add on a 5. And I'm going to take 1 away from middle digit. And lastly for H is the nearest whole number, which is a bit trickier. But again, you add on a 5 to the end. Now this doesn't mean it's 845. It means it's 84.5. Okay? And then 83.5. So we're taking the lower bound of n, so that's 13.905. We're taking the upper bound of d, which is 8.35, and the upper bound of h, which is 84.5. So now if we want to do our density, we have 13.905 over, there's actually something I didn't check. Okay. They've already given it in centimeters and kilograms. That's okay. So if you notice, it's in grams per centimeters cubed, which means I'm actually going to have to change this because this is in kilograms. I need to times that by 1,000. So instead of that, I'm literally just going to get rid of the decimal point. Cool. D is 8.35. No, not D. No, they do use D. That's a difficult letter to use because we have D over here. Alright, fine. 8.35 squared. H is 84.5. Shove it all on a calculator. Again, they wouldn't really ask you to do this without a calculator because it kind of defeats the purpose. You'd have to round, which means you would have to undo the hard work. And it's just a bit tedious, so they don't normally ask you to do that. 84.5. We get 2.36. I'm actually going to write quite a few digits. I'm probably going to go all the way up to the 5. If you want, you can write the whole thing. Actually, you know what? To show best practice, let me write the whole thing. I'm going to write the equals down here. I'm going to write 2.36015938. Now I'm going to repeat the process for the upper. Now, if I want to make this number as big as possible, you want the numerator to be big. Again, think of it. Compare 1 over 6 to 5 over 6. 5 over 6 is bigger. So we want the upper bound of m, which is 13.915. But again, we're not actually going to put the decimal point because we're turning it into kilograms, because we want our answer in grams per centimeter cubed, not kilograms per centimeter cubed. So I've times this by 1,000. We want the lower bound of d because, again, if we make the denominator smaller, it makes the overall number bigger, which is going to be 8.25. We want the lower bound of h for the exact same reason as d, 83.5. Shove that all in a calculator and let's see what we get. 13,915 over 83.5. And let's do that now. Let's just, all we're going to do is literally go through and change the digits. So 3, that should be a 2 now, right? Yeah. Whoa, I meant to press up. There we are. 1, 5. All done. And we're going to do 2.4484, blah, 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 blah. So, we have gotten 4 of these marks. Out of 6. Out of 5, sorry. How do we get the last bit? Now we need to actually give it to an appropriate degree of accuracy. So if you remember, this is the lower bound. This is the upper bound, okay? Now, the suitable degree of accuracy is just the accuracy at which both of these numbers are actually the same. So for example, if I round these to one significant figure, can you see I'd get the exact same value? They'd both be 2. But can I get more precise? Well, let's try 1 decimal place. If I round both of these to 1 decimal place, I get 2.4, right? Okay. What about 2 decimal places? Well, then I get 2.36 and 2.45. Those numbers are now different. So, to a suitable degree of accuracy, we can do 1 decimal place because both the upper bound and lower bound would round to the same number. So that is as accurate as we can be. If any of you want to do anything related to especially physics, engineering, architecture, etc. in the future, this is a really important concept because we round a hell of a lot because our values can't be infinitely accurate. And so we have to find a suitable degree of accuracy. And the way we do that is we find the lower bound, the upper bound, and we find the precision or, the degree of accuracy at which the upper and lower bound are the same. Because that means that is as accurate as we can be. So again, at 1 decimal place, both of these values are the same, which means that is our suitable degree of accuracy. So why is it appropriate? Simply put, because the upper and lower bound round to same value to 1 decimal place. That is it. Okay, so that might be a bit extra because I don't see this being taught very often because it doesn't come up very often, but that's exactly the reason why you want to do it. For 2 reasons. One, it's not just, oh, you'll only lose a mark, right? As in this final mark here. The actual reason why it screws students over is because they see this, but they don't make the connection that they can do upper and lower bounds. Which means they actually lose 5 marks, or 4 marks, or 3. They don't just lose 1 mark. So this is very good to know, just in case it comes up. It will save you up to 5 marks on the exam, which is around half a grade boundary. Pretty useful. This is already looking to be a very interesting set of proof questions, which add up to 6 marks in total. So, the first one, I would hope that this is a pretty free set of marks. You're just expanding technically triple brackets, even though there's not actually 3 sets of brackets. So I'd leave the x out the front, expand the inside, we get x squared. And we're going to get plus x minus x, so I'm not going to even bother writing that, minus 1. So then that leaves us with x cubed minus x, simply put. Now, this here seems like a very interesting fact. I'm not going to lie, this does seem a bit more like an A-level question. But, I mean, fair enough, it's still GCSE. In a list of 3 consecutive positive integers, at least one will be even and one will be a multiple of 3. So what does that mean? Well, consecutive means that they're next to each other. So let's look at the numbers 1, 2, 3. You can also have 2, 3, 4. You can have 3, 4, 5. These numbers are all next to each other, right? As in these lists. These 3 numbers are these 3 numbers. That means they're all consecutive. So what it's saying is, if you have positive integers that are next to each other, and it's a list of 3, at least one will be even and one will be a multiple of 3. Now, the multiple of 3 thing is actually obvious if you think about it. Remember, when you do your 3 times tables, you're counting in 3s. You're going 1, 2, 3, 4, 5, 6, 7, 8, 9. So, of course, if you have 3 consecutive numbers, one of them is going to be a multiple of 3, right? Because you're counting in 3s. It's the 3 times table. So that might be a bit obvious when you think about it. One of them being even, well, again, when you count with any 3, if you look at these lists, all of them have at least one even number, right? Now, some of them have 2, but again, that's at least 1. Again, hopefully that makes sense, because if you're counting in sets of 3, you're always going to go past an even number, because odd and even alternate. It goes odd, even, odd, even, odd, even. So if you count 3 of those numbers, there has to be at least one even number. Now, it might seem like a useless thing to say, which, I mean, I do get it. That is somewhat fair. But now it says that n is a positive integer greater than 1. Okay? Prove that n cubed minus n is a multiple of 6 for all possible values of n. Now, if you notice, there is a link between part A and part B. These two things are the same. All they've done is they've changed the variable, but it's the same thing. They've done this ideally to help you, and this is a skill you'll learn more in A-level, where you use part A's in part B's, and you use part B's in part C's, and you just keep going like that. It's less common now in GCSE, mainly because there aren't usually multiple parts in questions, to be honest, but we'll leave that. So prove it's a multiple of 6 for all possible values of n. Now, normally, whenever I tell students how to prove it's a multiple of 6, you're trying to prove that you can factorize out a 6. Now, if I look at this, there is no way in hell I can factorize out a 6, right? Neither of these numbers is necessarily divisible by 6. So that normal tactic doesn't work. But look, they've given you this information, and what do I always say about information? They have to give you enough to finish the question, and they never give you useless information, which means this thing here must work. Now, if I look back up here, can you see that this is actually a list of 3 consecutive numbers? We've got a number, x, we've got the number that comes after it, x plus 1, and the number that comes before it. In fact, if you want, you could rewrite this as x minus 1, x plus 1. So for example, if I look at this first row, x would be 2, x plus 1 is 3, x minus 1 is 1. If I look at the next set, x would be 3, then we have 4 on the right, 2 on the left. This is actually a list of 3 consecutive numbers. They've made this look very similar to this, which means I can just straight up write n plus 1, n minus 1. And if I really want to prove the point, I can make it n minus 1, n plus 1. So this is a list of 3 consecutive. Okay, fair enough, I should write positive as well. But how do I know it's positive? Right? Couldn't n be 0 and then we'd have a negative? Well, no, because it tells me n is bigger than 1, which means it can't. None of these numbers are going to be negative. Okay, so that gives me 1 mark. Where does the second mark come from? Well, I haven't proved it's a multiple of 6. What I have proved is that it's a list of 3 consecutive numbers, but have a look. At least one of them is even, and one of them is a multiple of 3. Multiples of 6 are even numbers that are multiples of 3. They are the even multiples of 3. So if I times them together, if I times an even and a multiple of 3, I will always get a multiple of 6. If I multiply an even number, if you actually have a look at the divisibility rules for different integers, it's actually kind of interesting. To prove something is a multiple of 6, you have to prove it's even, and you have to prove that it's a multiple of 3. So if I multiply an even and a multiple of 3, I get a multiple of 6, always. That is how you get the full marks. Sweet baby Jesus. That's fun. I hope that makes a bit of sense. But again, the idea here is at least one of these 3 numbers is going to be even. And and just one of them is going to be a multiple of 3. Now, if 2 of the numbers are even, well, an even times an even gives me an even, so I still have the same thing, even times a multiple of 3. Let's go. 2 to the power of 61 minus 1 is a prime number. Explain why 2 to the power of 61 plus 1 is a multiple of 3. Okay. So again, this is going back to this statement up here. In fact, if you really want to be pedantic, it's this one here. So if I use that, if 2 to the power of 61 minus 1 is prime, then what is 2 to the power of 61 going to be? Well, if we have a look at the question here, In a list of 3 consecutive positive integers, at least one has to be even and one is a multiple of 3. So, if the n minus 1 is prime, that means it's neither a multiple of 3 or an even number. So, what do I know? Well, that means 2 to the power of 61 must be an even number, which it is. Think about it. If I'm timesing 2 by itself, it's always going to be even, no matter what. So, is even. Which means, and, not multiple of 3. How do I know it's not a multiple of 3? Well, think about it. 2 to the power of 61 is the 2 times table up to 61. So, of course, it's not a multiple of 3. The 2 times table, again, especially when it's to the power of 61, will not be a multiple of 3. So, okay, let's keep going. Therefore, the first number is not even and it's not a multiple of 3. The second number is not a multiple of 3, but it is even. So the only option, because it says one of them has to be a multiple of 3, must be a multiple of 3. Because the other 2 numbers that it's next to are not multiples of 3. That is a very, very difficult proof question. I expect everyone should be able to do this, but B and C is incredibly difficult. I hope my thought process make a bit of sense and maybe you picked up something, but that is a very difficult question. Another pretty fat question. So the reason why this question is really interesting is part of the method is slightly different to what you might be expecting. So the diagram shows the triangle ABC, and you've probably seen questions like this where they give you an angle and they give you x and they just want you to find out, hey, what's x? But it tells us the area of the triangle is k root 3. And again, you may have seen questions where they give you the angle, they give you 2 sides that are surds or something like that, and then they'll say, oh, here's the area, find out what either x is or what the surd is, for example. But in this case, they actually give you both. They've combined the question, which is why it's a 7 marker. So questions can go up to 7 marks in GCSE. They have done before, especially when it comes to circles and stuff. But this is one of the few 7 markers I've seen outside of kind of coordinate geometry. So it's quite interesting. And there is a good reason for this. So we have to work out the exact value of k, and they've given me that the area is. So with my brain, I'm thinking, okay, I'm going to be using the formula half AB sine C. So why don't we write out that actual expression? So we're going to have k root 3 equals half. A is, well, don't forget, it's the sides that are next to it. So x minus 1, x plus 1. X plus 1. And then it's sine 120. Right. Okay. Now I'm already spotting a small issue. So it says find the exact value of k. So we're going to try and get k equals and then some stuff, right? It's probably going to be a surd because it says it's the exact value. But the thing is, I have x on the other side. That makes me unhappy because I can't get an exact value of k if I have x on this side. And if you really have a look, it's not going to go away, right? If we expand these brackets, the x's don't cancel out. So what do we do? Well, this is where the 7 marks comes in. What else could we do to try and work out what x is? Well, if you remember when I said there's 2 types of question, one with the area and one with using the cosine rule, well, then you're probably going to realize we've used the area, we're going to use the cosine rule now. And that's in order to work out x, because if I use the cosine rule, I'm going to have an expression that is only in x. So cosine rule would be 2x minus 1 squared. Remember, it's a squared equals, in fact, let me write out the equation as well, just to make it a little bit easier for you guys. The only letters that actually matter in this whole equation right here are the lowercase a and the capital A. B and C, it doesn't matter what they are. But you want the angle, capital A, to be opposite lowercase a. Other than that, it really doesn't make a difference. So you have x minus 1 squared plus x plus 1 squared, there we are, minus 2, x minus 1, x plus 1, equals 120. And we need to solve this. And you might be looking at this thinking, Jesus Christ. But if we expand and simplify, you'll realize it's actually not the end of the world. A lot of this stuff is going to cancel down and make it a little easier for us. So 2x minus 1 squared, so that'd be 4x squared minus 4x plus 1 equals x squared minus 2x plus 1 plus x squared plus 2x plus 1. So again, you can already see that like minus 2x and plus 2x are going to cancel. This one is, okay, so the first thing we probably want to do is do cos 120. You're not supposed to know what cos 120 is, so don't worry about just using a calculator. It's negative a half. Okay? What we could do then is do the minus 2 times the minus a half from this to get just 1. So we can just get rid of it, which would be really useful for me. So again, what I've done there, and I've decided not to do it all in one go, is this is minus a half, and obviously this is a minus 2. So minus 2 times minus a half, which is going to be plus 1. So let's go again. We can simplify as we go along as well. 4x squared minus 4x plus 1. X squared plus 2x, we're going to get... sorry, x squared plus x squared is going to be 2x squared, is what I was meant to say. Minus 2x plus 2x is gone, so that become plus 2 now. Then we're expanding this again, so we get plus x squared again. Then we're going to have no x terms because it's minus x and plus x. Then we're going to have minus 1. So now we can simplify one more time. 2x squared. No, 3x squared. I wish I could count. You know, that would be really useful. 3x squared plus 1. So now if I move everything over to the left-hand side, so I'm going to move this over to the left, we have x squared minus 4x, and that's it, equals 0. So we have either x minus 4, either x equals 0 or x is 4. And if we have a look, if x was 0, we would have one of the sides would be 0 minus 1, negative 1. And this side would be negative 1 as well. Can't happen. You can't have a negative length, which means x is actually equal to 4. Because we cannot have negative lengths. No negative lengths. Now again, if x was 0, one of the sides would be minus 1, the other side would be minus 1, and this side would be 1. So it doesn't work. So let's sub in x equals 4 into here now, and we might be able to move on. I mean, we should be able to move on and actually get our final answer. A half. We have 4 minus 1, which is 3, 4 plus 1, which is 5, and then sine 120. So let's multiply all of that on our calculator. So we have a half. That's not a half. That's a half. Let's move the calculator. Move. There we go. Thank you. 3, 5, and sine 120. Oh, okay. Oh, this isn't actually too bad at all. Equals 15 root 3 over 4. And if you notice, we're going to divide both sides by root 3, so those two cancel. All we get is k is equal to 15 over 4. Okay, I thought it'd be absurd, but fair enough. I'm happy that it isn't. That makes my life slightly easier. Technically, you could write that as a decimal too. 3.75 if you want to. But yeah, that's it. 7 marks is actually not that bad, realistically. Be careful with the expanding, be careful with the signs, the negative especially. That's where a lot of students make mistakes, but I'm actually pretty happy with that. This is a classic repeated percentage change question. If you're not happy with me saying repeated percentage change, it's compound interest. So Alfred studies animal populations on an island. The size of the animal population at 2014 was 2,500. It increases exponentially, so 20% per year. Using his assumption, so bear in mind this is an estimate, it's not going to be exact, so we could get a decimal. Just saying. Work out the size of the population. Well, why do I say it's repeated percentage change? Because what's happening is they're increasing by 20%, every single year. So, how do you use this, again, the repeated percentage change formula? Well, what you do is you take the original amount, you times by whatever the percentage is, to the power of the number of years, and that gives you the final amount. So if we sub in what we have here, we don't know the original amount, which is the population at the start of 2009, so I'm going to leave it as just the letter A. Now what about the percentage? Well, if you notice, it increases by 20%. So if the original was 100%, we're increasing by 20%, we're going to add on an additional 20%. So the percentage is 120%. Or 1.2 if you really want to be fancy. But you can just use the percentage button. Now, how many years? Be careful with this. There are 5 years between 2009 and 2014, so it's about 5. Should give me the final value, which is 2,500. So the original amount is simply 2,500 over the 120% to the power of 5. Again, I like to always link things to other things. I don't like memorizing formulas, personally, and I don't like memorizing different methods. So this is the exact same as compound interest. It's the exact same as repeated percentage change. That method will work for whether it's decreasing, increasing, whatever. Okay, so try and draw links to that, because this makes my life a lot easier. If I've done a lot of compound interest before, and I have, this question suddenly becomes a lot easier. Again, I like to use the percentage button on my calculator, because why make my life harder than it already is? So 120, and again you have that shift % button. If you want, you can change it to a decimal, so 1.2, and that would work. And we get, shockingly, a decimal number. So of course we need to round it, because you can't have 0.69 of a animal, right? So I'm going to write this, 0.69, ... So we're looking at 1005 at the beginning of this point in time. What about part B? Alfred's assumption is too high. Explain how your answer to part A is affected. So it's not 20%, it's less than 20%. So what I'm going to do is look for where I use that 20%. Well, I used it over here. I've divided by it. Now, if this number is actually meant to be smaller, and this is a really key thing, then that means the denominator of this fraction should be smaller, right? So how you answer to part A? This number should be smaller, which means the overall number should be bigger. Remember, link back to what we did in the previous question. This denominator is too big, which means our answer is too small. That's all you need to think about. Whenever they talk about these assumptions, look for where you use that number. Did you divide by that number, or did you times by it? If you times by it, then the number's too big. If you divided by it, the number's too small. So, the actual number, the actual population, would be bigger, because we've divided by a number that's too large. The actual number is smaller than that. This is I've seen this type of question before, but when I read it, it's actually very different, which is making me happy. So, we have a rectangular sheet of paper can be cut into 2 identical rectangular pieces. Remember, if it's 2 identical, then that means they're cutting it in half. So in this case, they're cutting it horizontally in half. In this case, they're cutting it vertically in half. And it changes the perimeter of the sheets of paper. So what's the perimeter of the original sheet? Because I don't know the dimensions, I'm going to call the dimensions x and y. Right, for the x-axis, right, the width and the height or the length, whatever you want to call it, doesn't matter. Now in this case, if I cut horizontally, the width is still x, but the height now, or the length, whatever you want to call it, is y over 2. The perimeter of each of the 2 pieces is 50. It doesn't actually say which one's which. Shouldn't make a difference. Yeah, it shouldn't make a difference, it's fine. So if I work out the perimeter of this rectangle, we have x plus y over 2 plus x plus y over 2 equals 50. Remember, it does say each of the 2 pieces. So we only need to do one, we don't need to double it. But this gives me 2x plus y equals 50. That's my first equation. You can probably see I'm going to get simultaneous equations. If I cut it the other way, well, the height remains the same, but the width now is x over 2. Do the same thing again. We're going to have x over 2 plus y plus x over 2 plus y equals 64. So that means we get x plus 2y equals, well, 64. So we have 2 equations, 2 unknowns. Oh my god, it's simultaneous equations. And then all we're going to do is work out x and y, work out the perimeter. 5 marks, job done, bish bash bosh, all good. Let's make... So if I want to organise these equations a bit nicer for me, just to make my life a little bit easier, I always put the one with the smaller answer on the bottom so I don't get negatives. So I'm going to try and eliminate x. So I'm going to times the top one by 2. So we get 2x plus 4y equals 128. And we get 2x plus y equals 50. Subtract the two equations. We get 3y equals 78. Yeah? Yeah? And then all we're doing is dividing that by 3 to find out y is 26. Then to find out x, let's sub it back into the original. We have x plus 2 times 26, which is 52, equals 64. So x plus 52, 64. So x is equal to 12. So the perimeter now is going to be x plus y plus y. So it's going to be 12 plus 12 plus 26, 26. So we get 24 plus 52, and we get 76 centimeters. There we go, 5 marks. Not bad. So again, it's just one of those disguised simultaneous equations. I reckon if you could get up to this, as in with the labeling, you would be able to get the full 5 marks here, because then it's a very easy simultaneous equation to do. But again, it's forming these equations, it's the starting bits that students get wrong. So it's not a case of, oh, I could get 4 out of 5. It's a case of, I can't do the first thing, so I'm going to get 0 out of 5. That's the brutal truth. Best way to do it, again, is using that good old-fashioned algebra. Label the unknown sides, and then see what happens. As a quick reminder, they're going to give you random situations in the future. I can't prepare you for all of them, but I can give you general advice. Always use letters for unknown things. And from there, look what the relationship is. It's the best piece of advice I can give you for algebra. A rearranging question. Cool. The quantity of heat delivered by an electric current is given by this. Yeah, cool. Rearrange to make I. Well, again, I like to get rid of the stuff that's not attached first. If I want I by itself, the first thing I might actually do, by the way, is I might actually just rewrite the expression like this, because I like have I equals. So the first thing I do is get rid of anything that's not attached. So that minus b is not attached to the I, so to speak. So if I add b to both sides, got my voice cracked, ATI squared, I get h plus b. Now I'm going to get rid of anything that is attached to I, but you want to get rid of the times first. You want to do this squaring thing absolutely last. So divide both sides by AT to get h plus b over AT. And the last thing you want to get rid of is the indices. So how do you get rid of a squaring? You square root both sides. So you get looks like we have a graph. Yeah, it's a kind of gradual decay like this, which makes sense because it's a squared graph. Work out the average rate of decrease between 0 and 800. Okay. Interesting. At first I thought we were going to have to use a gradient, but we don't need to, because they've asked for the average between 0 and 800. So what that means is, all we're going to do is take literally the difference in the overall things. So the average rate of decrease of the temperature between 0 and 800 will be the difference in the temperature. So it goes from 80 down to 32. So the difference in the temperature over how long it took to actually do that. Cool, that was nice and quick. Thank God I didn't need to use the gradient, because that's hella difficult for me. 0.06 because I'm on a computer. 0.06, I think it's no, it's degrees per second. So degrees Celsius per second. So again, average rate of decrease, all you're going to do is work out the decreases and divide it by how long it took. A rate, anything to do with rate, is always divided by time, because rate says how quickly something happens. That is a measure of time, right? How quickly something changes. The instantaneous rate of decrease of the temperature at t seconds is equal to 0.06 degrees. Okay, so how do you do this? What you need to do, and this actually isn't really possible for me to do on a computer, but what you're trying to look for is, you're going to try and draw a tangent which has a gradient of 0.06. So you're going to try and draw a tangent along here that has a gradient of 0.06 at whatever time that works, if that makes sense. That is your value for t. I really dislike this type of question because it's trial and error. So, for example, you know you're not going to draw a tangent all the way up here because that's a really steep line. You want it to be 0.06. So it's going to actually be a lot less steep. So you're probably going to look somewhere in the middle here. In the mark scheme, it says just at t equals 350. So anything around 350 because it's a very shallow decrease. Again, that's not really possible for me to do on the computer, unfortunately. But I would literally get a pencil and a ruler and draw a series of tangents and see which one's closest to it, and then refine it from there. So let's say you start with a tangent here and a tangent here. You can see if it's between these two. If it is, then you can get a bit more narrow and narrow and narrow. You do have 4 minutes to do it, so it's not the end of the world, but it is trial and error, which is kind of annoying. It's already looking like a fun question. So we have this circle that's been split up into 3 sections. We have x, we have 2x, and then bleh, that's something. When the arrow is spun, a 1, 2, or 3 can be scored, of course. And he works out his score by adding the 2 numbers he gets when he spins twice. And it says the probability of getting a total score of 4 is 16 over 81. Assuming that the thickness of the lines is... Okay, yeah, sure. Work out x. Perfect. So, this is a probability question. It's a very interesting probability question. But the idea here is we're going to use this information to work out what x is. So, if we just think of this in terms of, okay, we can score 1, 2, or 3. What are the different ways he could score 4? Well, he could get a 1 and then a 3, a 3 and then a 1, or a 2 and a 2. Those are the 3 ways he can do it. So all I need to do now is create expressions for all 3 of these combinations, add them up, and that should equal 16 over 81. That's it. Easy, right? Kind of, maybe, possibly. So, what would the probability of, let's say, getting a 1 be? Well, it would be the angle associated with 1 over the total angle in a circle. So it would be x over 360. So it's 1 and a 3, so we need to put the times. Well, what's the probability of getting a 3? Well, we don't know the angle on a 3. But if we know that the angles all add up to 360, we have x plus 2x plus this amount, whatever that amount is, plus blank, is equal to 360. So that amount there for the number 3 is going to be 360 minus 3x. So we can do x over 360 times 360 minus 3x over 360. Is there any easier way to write that? Not really. Actually, there is like a slightly easier way to write that, but we won't bother with that yet. 3 and a 1 will be the same thing, but the other way around, right? The probability of getting 3 is this. The probability of getting a 2, well, that's nice and easy. It's 2x over 360 times 2x over 360. Now, because there are 3 different ways of getting a score of 4, we need to add up all of the answers to this and then make that equal to 16 over 81. So let's multiply this out. We would get 360x minus 3x squared over 360 times 360. What would that be? I'm actually not... Yeah, let's just use a calculator. Whoopsies. Ah, that's why I don't know it. Okay, 129,600. We could simplify that. Let's leave it like this. This is going to be the exact same thing again. Lastly, we're going to have 4x squared over the exact same thing again. So let's now add up all of these 3 things. So if we're adding them, the good news is that they all have the same denominator. So I'm actually just adding the numerators. So 4x squared minus 3x squared is x squared, minus another 3x squared is minus 2x squared. Yeah? Yeah, minus 2x squared. Then we have 360 plus 360, so 720x. No numbers. So it's over 129,600. that should equal 16 over 81. So solving this, I would personally times both sides by 129,600. So we get negative 2x squared plus 720x equals 16 over 81 of all of that. So that's going to be fun. Answer times 16 over 81 gives me 25,600. Let's move everything to the right hand side. So we have 2x squared minus 720x plus 25,600. We're solving for x. For this question, definitely, I would recommend quadratic formula, unless you can... I'm not going to bother... I mean, you could just, like, you know, divide everything by 2. That's really not going to help you much in this case. Or you can use the good old-fashioned solve equation button on the calculator just to make your life a bit easier. So 2 minus 720. So just because the numbers are big doesn't mean it's anything bad. So let's press enter. We get x is either 320 or x equal to 40. Interesting, but it can't be both. So which one is it? It's a pretty good question. This is why I like this question. It's very layered. So it's actually not too bad. If x is 320, well, then we're going to have 320 plus 640. That's already bigger than a circle. So the only option is for x to equal 40. Now you could actually check this out by simply subbing in the values. So that'd be 40 plus 40 is 80 plus another that's 120. And then of course this one's 360 minus 120, so that's 240. 240 plus 120 does add up to a circle, so you definitely know it's this one. So that brings us to the end of the third paper. I'm going to try and find the second one, but the fourth one is going to come out shortly as well, probably in a week or so. And of course doing another foundation one as well. Again, look through this and try and try and learn from my thought processes. I'm always trying to just form equations and then solve them. That's all GCSE maths is, really. The difficulty is forming the equation. And if you guys are aiming for those 8s and 9s, if you can just form equations, even if you get the answer wrong, you can, generally speaking, get most of the marks, which will get you that 8 and 9. But it's all about mathematical thinking. If you're aiming for grade 8 and 9, I'm willing to bet most of you are also aiming to do A-level maths, where you're going to, again, have to think mathematically, which means you're going to form equations more than you're actually just going to be asked to solve them, okay? So, hope you all enjoy that. I'll leave the link to everything and all of the other different papers that I've done for grade 9s in the descriptions, but I'll leave you to it. Have a wonderful day.